Well, it is Youth Sabbath, and I picked a topic, as you can see in the slide there, of intelligent design. Just make sure yep, all right, good to go. And the reason I picked this topic, first of all, I am a science nerd, but also I think it's important for the youth. I think most of us here that are baptized know what we believe. We're convicted of God's existence. But to the youth out there, my kids and the other kids out there, I think this is an important topic because at some point you have to decide, is this my parents' religion or is this what I believe? What do I believe? Do I have convictions that run deep enough that I'm willing to literally or figuratively die on this hill, lose this job, end this relationship, do not pass go, collect $200, whatever the thing is? How grounded are you in what you believe? Can you explain what you believe? So the topic today is intelligent design. I'd like to begin with, has anyone out there ever seen an Indiana Jones movie? Yeah, most y'all, right? Or maybe some other movie about an explorer archaeologist that researches ancient cultures. Maybe it's I know my dad likes to watch National Geographic. They have programs sometimes on, ancient Egyptian pyramids or, Mayan cultures of Central and South America. And you see these explorers look over ancient artifacts and they talk about what the people must have been like. And, they get clues from their culture based on what was left behind, right? Shards of pottery, maybe tools, weapons, maybe artwork, cave etchings or drawings, right? Maybe even scraps of leather or ancient paper fragments that got preserved somehow. And they speak emphatically as if they know for certain that these things, had intelligent people behind them that created these things, right? Just based on the evidence left behind. But were any of these explorers alive when these ancient cultures existed? Did they meet any of the people in real life who left the artifacts and the ruins behind? Well, no, of course not. But they can see from the evidence that there were intelligent beings behind these creations left behind. Much in the same way, we too can be explorers of our own. We can look at the world around us and look for clues if we keep our eyes open. And we can gather information about what happened many years before we ever existed. We can look at those facts, scientific facts, which have been proven beyond a reasonable doubt, but we can come to different conclusions about the exact same set of facts that maybe some other people will come to a different conclusion than us. Just like the explorers I talked about, they can see the fact that there's something carved in that cave wall or what appears to be an ancient tool or weapon uncovered in excavation. They can see those things exist. They see it with their eyes. They can hold it with their hands, right? They're certain that they exist. But they could come to different conclusions about their findings, those facts. They could think to themselves, well, that's odd. I wonder what random forces etched into a rock wall what appears to be a person chasing a deer with a spear. Must have been some random lightning strike on that cave wall to create such an interesting coincidence. Or they can more logically determine, wow, someone a long time ago carved this artwork in a cave wall. There was thought, there was intelligence, there's planning and intentional action behind what I'm observing. Or they could think to themselves, wow, I wonder how molten globs of iron squirted out of a yet unseen volcano in the area and somehow randomly cooled into these shapes that just happen to look like the point of a spear or a knife, right? How'd that happen? Or they can more logically determine, wow, some ancient people figured out how to melt down iron ore and shape it and sharpen it into a spear for hunting and a knife for cutting up the meat from the hunt, right? Same facts, different conclusions. There are a lot of scientific facts out there that are true. They are facts. But some people come to wrong conclusions about these same facts. And that is what I'd like to discuss today. So the point of today's message is to show that mankind didn't happen by accident. We were designed by intelligent and omniscient beings, God our Father and Christ, our elder brother. Mankind didn't happen by accident. We were designed by intelligent beings. So today we'll be talking about intelligent design. This is kind of an outline for the message I'll be giving. First of all, what is intelligent design and why talk about it? I've kind of given you just a little bit of a teaser there, but we'll go into more detail. And then example number one, we'll be talking about DNA versus proteins. which came first? And this is kind of analogous to the chicken or the egg question, right? Example number 2, mRNA and protein synthesis. And the takeaway here is mutation protection included, and we'll see what that looks like. And then finally, we'll round it out with some closing thoughts. So first of all, what is intelligent design and why I talk about it? Intelligent design is the belief that certain features of the universe and of living beings are best explained by an intelligent cause, not an undirected and random process such as natural selection. The universe and life on Earth, those that believe in intelligent design, was not an accident, but a purposeful creation by a supremely powerful and intelligent being we call God. And I think this is important for our youth, anyone that's in school. My kids happen to be homeschooled, so we teach them a creationist perspective, but not everybody is homeschooled. So I think it's important for anybody that's maybe pursuing a career in medicine. We have, several nurses and nurse practitioners amongst us. I'm a pharmacist. I think it's important to realize that science doesn't contradict the Bible. If you understand the facts and you come to the right conclusions about those facts, actually science supports the Bible. So we shouldn't be afraid of science or think that, we're going to get brainwashed by evolutionists if we go pursue a degree in science. My faith and belief in God were actually strengthened, and I was more convicted of his existence as a result of the classes I took for my biochemistry and doctor of pharmacy degrees. And I think it's important for preaching the gospel to the entire world, not just Christians who already believe in the Bible. How else are we going to reach an atheist or somebody of some other religion that doesn't even believe in the Bible? You can't tell an atheist, well, the Bible says God created. That's not going to go over well with an atheist who doesn't believe in the Bible, right? We have to meet people at their level and communicate in a way that resonates with them. So whether you're a minister preaching locally in the congregation or even beyond Today TV, or somebody's sitting in a chair here today, or you're at home listening on Zoom, we're all expected to be ready to give an answer for the faith that, the hope and the faith that lies within us. And the belief, when our belief in God is challenged, do we have an answer relevant to the person doing the challenging, right? And again, this is especially important for you young people out there that have not committed to this way of life yet. Turn with me, or turn with me back at the slides back here. 1 Corinthians chapter 9, verses 19 through 23 says, "For I am free from all men. I've made myself," this is Paul speaking, "made myself a servant to all, that I might win the more. To the Jews I became a Jew, that I might win the Jews. To those who are under the law, as under the law, that I might win those who are under the law. To those who are without a law, as without a law, not being without law toward God, but under law toward Christ, that I might win those who are without law. To the weak I became as weak, that I might win the weak. I become all things to all men, that I might by all means save some. Now this I do for the gospel's sake, that I might be a partaker of it with you." So Paul, he's saying, I argued the law and the prophets' perspective to the Jews because that's what they believed in. But then he reasoned logically with the Greeks and other people because that's what they believed in. And if you look at Acts 17, he talks about the tomb of the unknown God to the pagans. He's like, that's who I'm talking about. So he reached people on their level, right? And that's what we're trying to do here today, is come at from scientific perspective, people that believe in science. This is a language that they can understand. You could reason with somebody. So example number 1, DNA versus proteins, AKA which came first, the chicken or the egg, right? So the classic question, which came first? How did an egg come into existence unless it was laid by a chicken? And how did a chicken come into existence unless it was laid by an egg? Hatched from an egg. I saw my wife like, yeah, hatched from an egg. Chickens lay eggs, eggs hatch into chickens. Got it. Facts are important. Most of y'all know we have like 30 or 40 chickens, right? Where do we get the first one from, right? Well, my wife's sister gave us some fertilized eggs from Texas and we hatched them. We also went to Tractor Supply and bought some eggs. So we started our flock with both chickens and eggs. And of course, they produce more chickens and more eggs. But where did Tractor Supply get theirs from? Well, they got it from the hat. Where do you trace this back? And where did the very first chicken or egg come from? This is the same question we're about to answer in terms of protein and DNA. So if DNA came into existence first, as most of you probably know, that's the coding, the instructions for how to create proteins and, all the cellular processes. if DNA came into existence first, and in my slide here, you can see these little dots are the DNA double helix. And in this diagram, it's these sticks. And then the proteins are these colorful coiled yellow and blue objects here. These are just two artist renderings of what DNA and proteins and the interactions they form. How could the DNA ever replicate itself if there were no proteins, of which many dozens of these proteins, as you can see here, are latched onto this DNA, and that's important for unraveling the DNA into the two halves and replicating it, putting all the pieces of the DNA. It's cutting a ladder in half, and then you have two halves of the ladder, you pull it apart, and you got other proteins that get to come and rebuild one half of the ladder, rebuild the other half of the ladder. Now you got two strands of DNA, right? Dozens of proteins are involved in this process. So, or if the proteins came into play first, but there was no, these are those structures that catalyze metabolism, creation of new cells, harvesting energy, breaking down the food you eat and turning into power for your cells. If they existed, but there's no DNA instructions on how to make new proteins, how could you ever create new proteins, right? Or think about it like this. This will get my son's attention. This is Carson's love language, computers and USB drives. Another way of looking at it, if you had a USB thumb drive, I almost said, CD or DVD ROM, but that would have like dated me. So we're going with the more modern lingo, a USB drive, and think of that as the DNA. That's the instructions on how to build a computer. Could you build a computer from just the information alone on that thumb drive if you didn't have a computer that you could plug it into and read the instructions? No. All right. What if you had a computer, keyboard, mouse, monitor, but you didn't have the USB drive with detailed instructions on how to build a computer, right? The keyboard, computer, mouse, that's like the proteins. That's what can unlock and read the information. If you don't have that, if you have that and you don't have the thumb drive, how are you going to build another computer? You can't just like take all the screws apart, because then, well, how do you refine the plastic? How do you mine the metal? How do you form the components? How do you make the microchip processor? And you got to build the components before you can even assemble it, right? So if you got the computer, you don't have the thumb drive with instructions, you can't build another computer. You got to have the information, right? It's the same conundrum with DNA and the proteins. The proteins are the machines that build and sustain the cells and can read and replicate the DNA, which is the thumb drive, right? Having one without the other would be entirely useless. This is another example here showing the complexity of it. You got proteins up here that are unzipping or untwisting it, and the proteins that are cutting these bonds, other proteins that are, matching up. It's called a primer that matches to the sequence, and it's kind of like the starting point for the DNA replication going this direction. This strand, it's got to be replicated that way. And then at the end, you got stuff that's sealing it up, spinning it back together so it can be packaged and stuffed back where it belongs until you need it again. Okay? So suggest, it's just mind-blowing to say, how did all of this come into play at the same time? And don't get lost in the details. If I'm using fancy terminology, it blows my mind talking about it. But just understand that if I can barely talk about this and your brain is melting down right now, right? That's the point, is that it had to be an intelligent force to design something so complex, right? So suggesting that just the DNA, as complex as it is, came into existence with no design, forethought, or creative focus on its own is incredibly implausible. Same with the proteins, suggesting that these structures that catalyze reactions and can zip and unzip the zipper and make a new zipper all at the same time, that all coming into play on its own is also very implausible. But suggesting that both the DNA and all the dozens of proteins involved came into existence at the same time in the same location on Earth in such a way that they were compatible with each other is utterly preposterous. Think about, I showed you in those coils, it's not just information and proteins. They have to interact. They have to, essentially speak the same language. It's not just that they both came into existence. They had to be compatible with each other. And not only are we talking dozens of proteins required to unzip the DNA and start replicating it, you need even more biochemical machinery than that just to manufacture the base pairs, right? The A, T, C, G, all the pieces that make up the ladder of the DNA, right? This is a very dumbed down and simplistic example of all the biochemical pathways needed to turn the stuff you eat into C, the RNA stuff. This is the G, guanine, adenosine, the G's and A's, the C, the T, the P, all that, right? You got to have proteins that are making all these things and managing all that. And that had to come into play at the same time. Or it doesn't matter if you have DNA and you got proteins, you don't have any more ladder rungs to build with, you're not going to be making a cell. So all this had to be in play at the same time, right? Now, taking this all a step further, again, most of you know I'm a pharmacist and I have a scientific background. That's, why I'm giving the speech today. A new position that I've recently taken at work has me involved in what's known as specialty pharmaceuticals. And some of you medical folk out there might know what that is, but for the whole group here, some specialty pharmaceuticals are maybe a pill, like a chemo pill that just requires extra monitoring. So they'll do extra hand holding with the patient, make sure and everything's squared away. But a lot of these are really expensive biological type injectable drugs. They're not simply chemicals like ibuprofen or antibiotic and pill you swallow. Like Humira, or a lot of the pharmaceutical commercials you hear are these really high-tech biopharmaceuticals. And they're highly complex proteins, typically like those coils I showed you, that treat some really deadly and debilitating diseases that a simple pill cannot fix, like hemophilia, for example. People just bleed out without these life-saving drugs. To create these highly complex proteins, guess what? There's no machine on earth that mankind has created that can match the ability of God's creation of mass producing these amazing protein substances. So how then are these miracle medications created? Well, essentially, mankind has harnessed the power of God's creation and used bacteria, mice, other mammals, and have hijacked their cells to mass produce these highly complex specialty medications. It's not as simple as throwing a few chemicals together to make an ibuprofen, like I said. And even that is complicated. I'm kind of dumbing that process down, right? We're talking about cutting out the DNA of bacteria and inserting new genes into those bacteria to compel them to make insulin, human insulin, for example, right? They grow up this batch of bacteria, then they kill off the bacteria once they mass produce these proteins, and then they got to centrifuge it out to purify the protein to give life-saving insulin to people. We're talking about injecting animals with harmful substances like snake venom or something to force their immune system to make proteins, antibodies, and then they have to drain out some of the blood from the horse or whatever the animal is, spin it down, and get the purified proteins. And that's why these medications are incredibly expensive. There's so much technology involved in manufacturing them at scale. And I'm thankful to the brilliant human minds that made these things possible. It's not a slam against those scientists at all. They've created wonderful gifts to people, life-sustaining medications. And, but let's give credit where credit is due, right? We're just literally hijacking God's creation because he can do it better than we can. So now if mankind cannot make a machine on purpose that does a better job, faster, more efficient, at the scale with which we need to produce these pharmacy, especially pharmacy medications, we turn to the natural world, right? I have a hard time believing that we have to turn to what happened accidentally and that it works better than what we can do on purpose. Like, think about it. We can't do on purpose what happened on accident, right? And evolutionists would argue that what happened by chance in nature is better than what we can do on purpose. To me, that makes zero sense, right? And just to illustrate the complexity of what I'm attempting to describe here, I found a video on YouTube, and hopefully this works, right? And it's an animation. Clearly, there's not video cameras tiny enough to fit inside of cells, right? But through, scanning electron microscopes and other technology, we know what protein structures look like, and we know some of the chemical interactions. And this is, an animated film showing what, if you could zoom inside the cell and see what was going on, this is literally what's going on. These are just white blood cells traveling through a blood vessel. These are various protein interactions in the cell interacting with the lipid membrane. don't worry about the sound, it's fine. These are proteins floating within the lipid membrane, other proteins interacting. See how they move as if they're mechanical machines? This is not simple stuff, right? These are, I believe, actin fibers in muscle cells, and they slide across each other to contract your muscles. This is a closer look at the structure. This doesn't look accidental or random to me at all. These proteins just randomly coming together in the chemical bonds in these filaments. And another protein comes along and cuts it like it with scissors. These are microtubules forming that when a cell splits and it pulls the sets of chromosomes apart, they get pulled along. This is like a walking machine that's pulling a giant blob that's containing like proteins. And these fibers are all around your cell inside. It's like highways to transport. They're like 18-wheelers walking down highways to transport stuff to where it needs to go. This is the nucleus and little segments of RNA, which we talked about, spitting out of the nucleus. And little yellow balls are the ribosomes, and they form, and they start reading that, and that's the protein spitting out the little yellow thing coming out the back. Like this, literally what I showed you in the pictures. That's another protein being synthesized. You can see it going back into the nucleus. That's a ribosome splitting apart. These are little vesicles, cylinders, transported like a lipid bubble formed in the protein side of it. It's like a bucket, and these little guys carry it to where it needs to go. This Golgi apparatus, it's like an Amazon warehouse, like trucks of certain proteins come in for they're being produced, and then they leave in other vesicles to go out to the cell. And this is when the bubble kind of hits lipid membrane. It opens up and deposits the stuff where it needs to go. I'm not sure what those guys are. And at the end here, this is, again, outside of the cell. This is a white blood cell in your blood vessels. It can squeeze in between cells needs to go kill virus, bacteria, whatever it's facing, and none of the blood leaks out. It can get down that fat, fit in between as if nothing ever happened. So pretty impressive if you ask me. All right. Moving on. And some of this we saw in the film here, right? So now we're going to talk about mRNA and protein synthesis, get into a little more detail on how the proteins are made. And the subtitle here is mutation protection is included. And again, I'm going to get into some detail here, and it's okay, don't get lost in the terminology, but just appreciate the interdependencies and the complexity here. So genes are expressed through a process called protein synthesis. So DNA strand is uncoiled, like we saw in the pictures, and a mere copy of the DNA strand is created, which is called mRNA, which is a messenger RNA. Excuse me. And this process is called transcription. So as the mRNA is created, the DNA strand is coiled back up to be used again later, right? Kind of like the DNA replication, but instead of making another copy of the instructions, this is opening up the instructions to actually build something from the instructions. Now, that's what the mRNA molecule does. So the strand is uncoiled by stuff, and then an mRNA template is made like that. And that was the things you saw squirting out of the little holes out of the nucleus into the cytoplasm of the cell. And that's just this codes or instructions here, okay? And then that mRNA is read or translated by a ribosome. And that was a little two-piece thing that came on the strand and started reading it, right? And then the tRNA or transfer RNA molecules interpret the sets of 3 base pairs and determine the order attached amino acids or the building blocks of proteins. So this is a tRNA, and there's 3 parts to it here. So the mRNA molecule, it's groups of 3 base pairs make an instruction, right? And then so that's called a codon, is that 3 base pair. And then the anticodon is kind of like the complementary piece that it matches up to. So like if this was a lock, this would be like the key that matches up to it, right? So only one key will fit each unique combination. The tRNA is kind of the stick between the anticodon and this amino acid. And then the amino acid is the little dots here. As this guy moves along, this one falls off, and then the new one comes into place here as the ribosome moves along the RNA, and this chain gets longer and longer, right? And that's the little yellow coily guy that you saw coming off those things. And as the protein's being built, it's got positive and negative charges, so it's folding itself like a piece of origami as it's coming off this process. It's incredibly complex. So imagine the fact there's a 20 known amino acids, which is these little balls here, 20 different ones, the different combinations make up the proteins. And you can see again here, this is the little bit closer zoomed up version of it showing the process as this one attaches, it links to the next amino acid, and then these guys fall off and it keeps on reading. Now, because there's 4 different base pairs, CAGT, and they're in combinations or groups of 3, it gives us 4 times 4 times 4 possibilities, or 64 unique CAGT, CA, whatever combinations. And in the mRNA, it's the T is substituted for U, so we're going to be talking CAGU. But basically, 64 possible combinations, but you have 20 possible protein or amino acids stuck in the end. So given the randomness of evolution, do a little math here, I would guess or postulate that there would be roughly 3 codons per potential amino acid, right? If you took 64 possibilities divided by 20 choices, you get roughly 1 in 3 chance. So there'd be 3 per each, right? A couple might have 4. Well, not exactly random as this chart is mapped out. So this shows the possibilities of the codons UUU, UUC, UUA, etc., right? Or UC, so it's like a matrix of starts with a U and then a U and then a UCGA, and it's every combination, all 64 possibilities in this chart here. Raise your hand if you think this looks random. No, does not look random to me. There's built-in mutation resistance by grouping similar sets together. This is called a silent mutation. So what that means is basically, let's say your DNA made a mistake. This is phenylalanine, that's the amino acid. And if you had UUU in the sequence, but then your DNA made a mistake and it made UUC instead in the replication, what would happen? Nothing. Nothing bad would happen because it's still phenylalanine, right? Now, if you imagine these codes were all smattered all over the place, right? And they weren't adjacent to each other, then a 1 base substitution from a U to C could be a catastrophic issue. So not only do we have proofreading stuff in our DNA that actually checks for mistakes and will replace it, even if a mistake is made, we have built-in mutation resistance. This is called a silent mutation, meaning it's technically a mutation, but it doesn't result in any harm to the body. And there's a further layer of built-in mutation resistance. So these are phenylalanine and then leucine. And you can see this one's only got 2, this one's got 6. They're not all 3 on average as we would expected, and they're not randomly placed. All the yellow ones you can't see maybe here, but they're called hydrophobic amino acids, which means they're kind of, think of like oil resists water. So they get along together, right? All the white ones are hydrophilic, not charged, but prefer water. The blue ones are positive charge and the red ones are negative charge. So even if you substitute aspartamine for glutamine, it's technically a different amino acid, but any of these within here have the same charge, which means, again, you're not likely to have a non-functional protein. There's a good chance it'll still work because the chemical properties are so similar. So again, not only are the amino acids organized amongst themselves, but within the groups, similar chemical varieties are organized together. This is not random. This doesn't seem like a system of where we had 5 amino acids and then we mutated, we had a 6th, and then we bolted on a 7th, and then we had an 8th, and that would be a total jumbled mess. This was designed from the beginning of, we're going to have 20 and this is how we're going to do it. And intelligence behind, the silent mutation protection was built into this diagram, right? Romans chapter 1, verses 20 to 25 reads, "For since the beginning of the world, his invisible attributes are clearly seen. And I think it's fascinating that, like, yeah, it's invisible to the human eye, but you see it here today. You can see it with your own eyes. That even if Paul back then knew it was invisible, but it was there, how much less excuse do we have today when we can see it with our own eyes? It is no longer visible. Being understood by the things that are made, even as eternal power and Godhead, so that we and they are without excuse. Because although they knew God, they did not glorify him as God, nor were thankful, but they become futile in their thoughts, and their foolish hearts were darkened. Professing to be wise, they became fools. There are a lot of scientists and smart people out there that think they have it all figured out, and they are smart on one level, but this here, them denying the source of it, knowing what they know, they are without excuse. And God says they're fools. They changed the glory of the incorruptible God into an image made like corruptible man and birds and four-footed animals and creeping things. Therefore God gave them up to their uncleanness and the lust of their hearts, to dishonor their bodies among themselves, who exchanged the truth of God for the lie, and worshipped and served the creature rather than the Creator, who is blessed forever. Amen. So mankind has gained a lot of knowledge through science, but he's drawn the wrong conclusions from the data. After all, isn't it called the theory of evolution and not the law of evolution? I've heard of the law of gravity. I haven't heard the law of evolution. Rather than worship the Creator, much of mankind is elected to worship the creation. Pagans bow down to nature and creation the same way much of the scientific community bows down to the God of evolution and Darwinism. If scientists are impressed by God's creation, how much more should we be impressed by the one who created it all? If King David could look up into the heavens and see God's glory, he thought, oh, those are some pretty little dots in the air. There must be a God. He didn't know it was billions of light years away, giant balls of burning gas, millions of degrees. He had no clue or concept to the details. Just like Paul said, the unseen attributes we know now, and we still just scratch the surface. Do we really know it all? We only know what we know, right? Now, I don't think we should, bury our heads in the sand when it comes to science and evolution, but we need to challenge the conclusions that some of these scientists have come to based on the data. And I believe that the best defense is a good offense. And while we shouldn't be combative with people, we should be ready to give an answer for the hope that lies within us. Whether we're speaking to, a Southern Baptist explaining from the scripture why we don't believe God is a Trinity, or if we're discussing the evidence of creation, talking with an atheist that believes in theory of evolution, right? We should be prepared and have a message and a belief system and why we believe what we believe. So remember the last time that you watched Indiana Jones or National Geographic, next time somebody tries to tell you, remember that example of, oh, this just happened on accident. Well, you have examples now, the USB or the computer, which came first? I'm trying to arm us with rational arguments that, of course, we need to turn to the Bible for moral instruction, but I'm saying you can't pull out your Bible to debate an atheist. It's not going to work, right? So we have to have scientific reasons that are facts that we can arm ourselves with to say, this is where I stand and this is why, right? Are not archaeologists and other scientists 100% convinced that these intelligent and advanced civilizations existed based on the evidence, even though they've never met those people in person, right? Well, have you never met God? Well, you never met the Mayans, and yet you're convinced that they were intelligent and that they existed based on the evidence in front of you, right? The evidence is all around us, and we should be more convinced of God's existence based on the more scientific breakthroughs we discover, right? When Darwin wrote on the origin of species and described his theory of evolution, scientific observation was limited to this and a simple microscope, right? The human eye. Cells looked like blobs of goo under a simple light microscope. He couldn't see those microfilaments and a little protein, looked like a pair of pants walking, pulling this giant load behind it, right? He couldn't see any of that in the microscope. He had no knowledge of DNA and proteins or complex biochemical reactions. He couldn't observe any of that with the scientific instruments of his time. If Darwin knew what we know today, would he have still come to the same conclusion based on new understanding and new data? I don't know, but it's interesting to think about, and I'd like to ask him one day if I ever meet him. So I hope my presentation on intelligent design today will give you some things to think about and some points of discussion, and hopefully allow all of us to have a greater appreciation and awe of God, our intelligent designer.